Thank you, everyone, for joining us this evening. We have a special presentation by Professor Mitch Wagener of the Biology Department at Western Connecticut State University. And the topic tonight is of high interest, history and natural history of stone walls. So, and I believe, Mitch, you were saying this is a talk that you do often.
Yeah, this is yeah, in fact I'm giving this same talk at the Torrington Historical Society just tomorrow.
Oh, excellent, excellent. And without further ado, I know we've been postponed quite a few times, but let's get started. Professor Wagner, you have the con, sir.
Okay, thank you. Well, I have been in Danbury in Connecticut at a professor at Western Connecticut State University since 1996. I am not originally from Connecticut. I'm not originally from the East Coast. And so when I came here and started stomping around our nature preserve in the West Side campus, which you're all welcome to go stomp around on if you like, I noticed that there were landscape forms which were very different than what I was used to. I grew up in Missouri, and the part of Missouri that was never glaciated. The glaciers in Missouri only went as far south as where the Missouri River is, which is not even halfway between north and south. And that, where the glaciers have been is a profound effect on how things are now. From Missouri, I went to Alaska, which is another place which is about as different as it can be from Connecticut. And so when I got here, it was quite the interesting thing for me as a budding young soil ecologist straight off from PhD school at the University of Alaska to look at them and try to figure out their place in the history of the area and the natural history of the organisms, so on. I always start with a version of this picture. I have a winter picture, which I should have probably put on, but of course we are phasing out winter at the moment and hurrying into spring, I hope. For those of you who may have been Western alums at some point, this is a science building, and when I arrived in 1996, this is where the football field was, and the science building was Higgins. So, point of reference. Pushing the right buttons. There we go. So I arrived, and in the summer or the end of summer of 1996 and took students out in the field at the West Side campus where we have a lovely little nature preserve, which is in large part bits of the Gregory family dairy farm from way back. Okay, that's part of the story I'll be telling. And I noticed all these stones in regular arrangement, and obviously it was a fence of some sort. Obviously it was quite old, and I started looking around and asking around and getting the story behind it. Turned out that there is a gentleman at UConn, and I know he's now retired, who wrote one of the books on stone walls in Connecticut, is one of the experts, and he is, and I can't remember his name at the moment, but he and I actually overlapped in Alaska. Um, he was in the building next to the one I was in for at least a short while there. All right, let's see here. Pushing the button again. Now, it all goes back to the ice ages. One of the things about Earth is that from the beginning, there have been periodic ice ages. There were some really cold ice ages, which now ecologists and geologists call snowball Earth. There was an episode that froze the Earth almost to the equator, and it happened right before, in geological time, right before, meaning millions of years before we have first evidence that animals show up, animals showing up in the fossil record. And we can study this, we can study these ice ages and get a pretty good idea of the timing of them, the ones that are relatively recent, recent meaning the last 500,000 years. Going back farther, the farther you go back into Earth's history, the harder it is to be precise about these things. And the way we study them, at least for the last 500,000 years, is by looking at ice. Ice in Antarctica, ice in Greenland to a certain extent, because this is old ice. The ice in Antarctica in particular. As it turns out that Antarctica, pardon me, the ice is made of water and water contains oxygen. And there are more than one form of oxygen. Oxygen 16, which is the most common. There's oxygen 17 and oxygen 18, which have extra little bits in extra neutrons in the nucleus, which make them not react different chemically, but react more slowly than because they're heavier than the most common form of oxygen. And so hardy souls who are well dressed going out into Antarctica, it's really cold. So I hear. I've never been there, but I spent 14 years in Alaska, so I know cold. And you take a drill and you pull out a core and you look at the ringed layers that are like tree rings. There's Antarctica. Actually, that's Greenland, but much of Antarctica looks like that. Oh, all right. Let me go back to that. If you look at an ice core that is cut from a old glacier, you have rings in it. Look like the growth rings in a log. It's like tree rings. And you can see how thick they are. It tells you something about how wet or dry the environment was. You can find little bits of oxygen, water, which you then analyze for the amount of C14 and C18 to get some idea how cold it was at that time. And you can pull out little tiny bubbles of air and analyze it to see what the atmosphere was like at the time. It's an expensive way of doing research, but it is the only way to find out these things precisely. And we also have to make sure that the ice doesn't melt. A ice core from Antarctica that has all of this beautiful information in it, you let it melt and it's just water. Well, so we're going to be talking about the ebbs and flows of ice ages first, and then we'll settle into the end of the last ice age and take it from there. Humans as a modern group, the modern version of humans, there's any organism with the genus of Homo means man, and that is a group of organisms we call humans. Okay, there's previous species, previous to Earth, but Homo sapiens, the one that you and I belong to, shows up about 250,000 years ago. Okay. We can also go back and get an idea how recently our most common ancestor appeared. And that is by looking at mitochondrial DNA in cells, which you only inherit from mom. And so they're not mixing between mom and dad like most of the other cells in people. And so we get some idea of how fast they mutate, and we can go back in time and figure it out. And it was 200,000 years ago, and the mother of us all was mitochondrial Eve. That's what she's called. And she was roaming on the savannas of East Africa. And then we spread out from there. All right. But right now, we're talking about Connecticut in the 21st century. Now, if we go back 16,000 years, at the height of the last ice age, Where we are now, assuming you're in the Danbury area or in Connecticut in general, where we are now was under a mile thick layer of ice. Okay. And it was nearing the end of the last ice age. Climate was warming up to a point where the ice was melting in place. And anything that was carried by that ice is dropped. And that's part of our story too. Well, so 21,000 years ago, the ice, by the way, the ice previously, that funky thing about ice is that it moves, it flows downhill when it's getting colder. But when it recedes, it's melting in place and dropping whatever it had. So when it's pushing forward, it's picking up rocks and whatnot as it moves forward. And then when it stops moving and when it starts to melt in place, all that stuff falls down. And the front edge of that glacier as it's moving forward is like the blade of a bulldozer and can pile up stuff in front of it, which is exactly how Long Island was formed. Okay. Long Island was a what's called a terminal moraine, a big pile of stuff, rocks and sand and so on, that were pushed there as the ice was moving down from the north. When the ice and in 21,000 years ago, that's about where the edge of the glacier was. When the ice began to melt, you get a big pile of stuff. Now, as the ice melted, the sea level came up because the ice that is in the water that's in the ice isn't in the ocean. And so the sea level came up and eventually flowed around what is Long Island now, made it an island, made Long Island Sound and all that stuff. Okay, it's more than one talk's worth of information. Okay, so 21,000 years it was about there, 20 or 14,000 years it was up in the middle of Vermont, New Hampshire. Okay, and the melting of that glacier formed a number of rivers, including the Connecticut River that flows between Vermont, New Hampshire, and down through Massachusetts and down through Hartford, and okay. When a ice sheet melts, it is carrying a lot of stuff, as I've said. Some of it's big rocks, some of it's little tiny ground up bits of very fine dust, fine enough to be suspended by the water as it's flowing downhill. And so when the ice melts, you get this what's called a braided stream. There's still plenty of these in Alaska you can see in Denali National Park, where the big mountain is. And this braided stream is of this shape rather than a single flow, just because it's carrying so much dust and whatnot. It's called glacial flour. And it leaves behind a number of particular kinds of landscape features which geologists love to categorize and study, including eskers and drumlins and moraines. Moraines are the piles of stuff left behind that are roughly parallel to the edge of the glacier that moves. And they'll also leave chunks of ice that are partially buried, which when they melt form kettle lakes. And we have some of those in Connecticut as well. There's a state park named after some of those that you can go visit. Whole bunch of these different kinds of landscape features. This is what a modern glacial melt stream looks like. And you can see it's all braided. You can't really see, but you'll see it in a minute, how gray the water is. And you can see that this glacier is receding.
As we look ahead to tonight, 39, 40 degrees, winds out of the northwest to about 10.
Not part of the story. Yeah.
I went ahead and muted it.
Yeah, okay. So this is a glacial flower stream in Alaska. It's probably in the national park. And you can see how gray the water is. And it's great because it's got all that ground up rock and stuff in it. And it's really cold. You can if you go up there, you can take a rubber raft trip down the Nenana River. It's pretty wild and woolly, but it's also really cold. And you're dressed up for it. Um, Such as Exhibit A. Here it is. Here's rubber rafts that you can take down the you can see how gray the Nenana River is. One of the things that occurs in Alaska, this is me, by the way, in 1984, when I was working on my master's degree in Alaska, and this is the only picture I have of me wearing snowshoes, so I had to put it in. One of the things that happens is you get kind of like mini glaciers that form as the local rivers freeze and crack, and water flows up and forms another layer up in them. And this is what I'm standing on up in sort northeast of Fairbanks and Birch Creek. All right, now the glacier is melted, or mostly in a area. This picture is taken in Greenland, but it could be Connecticut of 16,000 years ago. And what we see is the loose rocks and sand and whatnot is stuff that was left by the glaciers. You can see that the big rocks are kind of rounded off. They're eroded. They're rounded off by the act of the glacier. Ice is very, very strong, even though it's very, very slow. And so these chunks that we now see incorporated into stone walls by the old farmers, which is a story I'll tell, are all bits and pieces that were eroded off the White and Green Mountains of Vermont, New Hampshire, the ones that are here. If you go other parts, if you go up into Maine, they're from the adjacent mountains. And at one point before the last glaciation, the White and Green Mountains were the height that the Himalayas are now. But 4 episodes of glaciers running over the top of them ground them down to nubs of a sort. And so this is what they were once like. This is the Himalayas. And this is what they are now. Still respectable mountains for hiking and skiing and recreation and beauty and all that stuff, but not the Himalayas. And those little bits that are the difference between that and this, well, they all brought them to Connecticut and other places down here. And so we have in Connecticut tons, this is over near Ledyard, I think, whole tons of these stones that are rounded off and were left here. Now, what happens after you have a big pile of rocks deposited is you have a ecological process called succession, primary succession. When you have a big pile of rocks that were deposited by glaciers, there's no soil there, really. It's just rocks and some sand and some other things, but it's just rocks. There isn't really enough organic matter to even call it anything else. And over time, you have a process where the rocks are further weathered. You get lichens and mosses growing on them, which gradually die, senesce and die, and leave little bits of organic matter from the little dead mosses and stuff, and lichens, in which then it forms the first basis of the soil. And gradually over time, you get a little bit of soil and you get weathering, freezing and thawing and all that stuff of the rocks, which breaks them up into smaller pieces, some of them. And then you start having the seeds of windblown plants blow in. Things like dandelions, although dandelions are not native, so they wouldn't have been here at that time. But broom sedge and things like that. And gradually, as generation after generation of those plants blow in, grow, die, senesce, decompose, get incorporated into soil, you have a soil buildup. And then as the soil builds up, that allows for other kinds of plants to come in too. Things that have more of a root system, like woody shrubs, and then trees. And then finally, you get a community of trees, which is called the climax community, because they are the last community you have before the next calamity comes along, the fire, the next ice age for that matter, or so on. And so they are what you associate with that area. So around here, the climax community was oaks, hickories, and at one point American chestnut. Not too many of them around a lot anymore. But that's another story which I could tell at some point, but not today. And so we characterize an ecosystem by its climax community. And the trees that we have will stay and replace themselves as they get old and die until some catastrophe like humans come along and knock them down and turn it into a golf course, or a backyard for someone's house or so on. But here's an experiment you can try. This year, don't mow your lawn, and don't continue not mowing your lawn for the next 50 years. What you'll see is you'll get those trees back. Now, humans show up, going back to the anatomically modern humans, we show up on Earth 65,000 years ago, which isn't very long. And there were groups of people who left East Africa and ended up in one of the first groups went down and became the Aboriginal people of Australia. And later on, when the Ice Age was over, around 16,000 years ago, and they could walk across the Bering Land Bridge to the New World, they came and colonized the New World. First North America, then eventually South America. And here they are, and here they were. Here they were when Europeans first show up. This time, these people did not have benefit of iron tools, and they were hunters and gatherers. They did not have the ability to, did not have the knowledge or technology to domesticate plants and animals, which we can do now, and we've been able to do for a while. Okay, it's called the Paleolithic in anthropological terms. And so, the people of this time had to go out and poke things, big things, with pointy sticks, and hope that they didn't get squashed in the process. One of the animals that they would sometimes hunt were elephants, and these elephants existed in the New World, same time humans did early on, and we know them as woolly mammoths and mastodons. And woolly mammoths were all over the place. In my office, I've got a slice, it's about this big around, of a woolly mammoth tusk. It's about an inch thick, that a fellow gave me in Siberia years ago. And the natives, built their, invented their own technology suitable to, the resources they had to work with, and they came up with different types of arrowheads that, serve different purposes, including the Clovis and Folsom points. Roughly 12,000 to 9,500 years ago, some of those hunter-gatherers figured out how to domesticate plants and animals and became farmers over time. The climate was rapidly warming after the Ice Age, in a time called an interglacial. And different points found plants and animals that were domesticable, and and societies that were full-time farmers and began to use metal tools are called Neolithic. That's how anthropologists will categorize them. The first animal which was domesticated was this lovely creature who's lurking about here somewhere, not the one on the left. That's Canis lupus, which is the wolf. The cold-blooded killer on the right is Canis lupus familiaris, also known as my dog Ringo. And he's sleeping on a chair or something. And they're the same species. At some point, wolves decided that an alternative lifestyle for them was to hang around with humans and eat our trash. And it was, we would throw away bones after we'd been hunting and so on. And they would eat them. And it was easier than chasing down their own deer. And so they, over time, evolve those characteristics which would make them more tolerable to us, like they would be willing to let us decide who they mate with, which allowed us to breed all these crazy varieties of animals, dogs. The first plant domesticated was the calabash, which was domesticated and used as a container and not as a food source. It was used for carrying water and food, and this is from Asia. And all these things, the plants that we're familiar with, peas and wheat and millet and rice and soybeans and all that, were evolved by ingenious humans who figured out ways to grow them in such a way that they could change those plants and animals over time to make them better for us. And it has certainly included Native Americans who domesticated squash and maize, corn, beans, manioc, potatoes, and peppers, and so on, and other things. And wheat was the first food crop that was domesticated in the area of the Middle East. Once people could grow this stuff and not have to just go looking for it, then life changed for them. Food was more reliable at that point. Fewer old people starved, fewer babies starved. And so the implications of agriculture for humans, and this applies to this day, are they allowed us to settle down and form villages and towns. It also allowed us to radically modify our environment because we are plowing the same field and planting corn and year after year after year, and we had to develop an understanding of agriculture, and all that allowed us to support higher human populations, which meant that people could diversify and find the jobs they were good at. Some people are good at making pottery, some people are good at growing food and so on. Some were good at going out and hunting and so on. So and then we developed trading economies and governments and religions and art and the whole bit. Native Americans here, they domesticated squash and gourds and corn and some species of beans, and it was a decent diet. Three sisters. The natives that were found in this area most recently before when the Europeans show up, were the Wampano Kiripi. Okay. They, Paleo Indians, meaning people of unknown language, what language they spoke, arrived 10,000 years ago. And the Algonquin speakers, of which the Wampanoas were, arrived 2,000 years ago, and agriculture moved in at about 1,000 years ago. In 1633, there was an epidemic drastically reducing the native population. It's called the Great Dying, and it has to do with contact between Europeans who had resistance to certain diseases they got from their farm animals coming in contact with Native Americans that did not have that resistance. And the lifestyles of the Wampano was to move around. It wasn't settled. There weren't permanent shelters made. They would move from the areas where they would grow corn during the summer, and then they'd go out to wherever the fish were running at that appropriate time, and then they go to certain areas where they could find deer to hunt in the winter and so on, and they'd move around. Okay, perfectly rational way to make a living. In fact, it was the way they needed to live in order to make a living. The Algonquians is a large group, and it goes all the way out to the Blackfoot in the western part of the United States. It's a language. It's a language thing, not a ethnicity thing as such. Now, Europeans show up and gain access to land in some way. Maybe it was gentle and equitable. Maybe it wasn't. Probably varied a lot. Probably some of each. And the notion of land use to a European was vastly different. It was you clear an area, you basically change it to suit yourself, and you stay put. You don't go moving around. You may go on a fishing trip or a hunting trip, but you're not moving around at different, at different to different areas. You still have the homestead where you live, and it's the hill you die on. And they noticed that these stones were every spring. The frosting, the freezing of the soil would push these big round stones up to the surface, which was a pain because those stones got in the way of their plows and were, something they'd have to walk around and deal with. And so what they did is they piled them up at the edge and used them as fences. By this time, they had cleared out a lot of the wood to use as firewood and other things, and so they needed something to build fences with, and the stones were there. The other thing is that the value of domestic animals brought from Europe was very high. Your neighbor's sheep were more valuable than your cabbages that you had growing in your garden. Therefore, the law said that it was your responsibility to protect your cabbages to keep the neighbor's goats out, which meant you could do walls. Okay, and they did. And so these walls then were put up to keep the neighbor's goats out of your cabbages, and because it was necessary to clear stones out of the forest, out of the fields, in order to be able to run your plow through it. The Danbury area was colonized by a relatively small number, 12 or 13 different families of English who acquired land. Don't know the details on how they acquired it. And one of those families are the Gregories. Gregory family had a farm about right there. This is Hiram Gregory, who was the owner and farmer of this land in the 1860s, right after the Civil War. But there was maps that were made showing the different family homesteads at different times because they didn't change. Okay. Now, the Gregory family, their farm, what Hiram farmed in 1867 is most of that is part of the West Side campus in Danbury. And you can see from high altitude photographs that the state made some years ago, I assume it's the state, maybe it was the feds. You can see the stone walls that are left over from the Gregory farm. Okay. There's also, I've trooped all through this area, and this is the planning map the university uses, and I ground truthed all the stone walls, and there is one area that looks for all the world like a dip tank. Like they had sheep, they did, and you would force the sheep to swim through this little pond full of acrocide that would kill the mites and ticks and stuff. And it's pretty standard practice for were taken care of, or at least it was in those days, of of, domestic animals. And you can see these stone walls. You can see the gaps in the walls, which was where the farmers' fields were. There would be wooden gates that were closing off those areas and so on. And it's quite fascinating. And you can see, if you know how to read the walls, you can see which of the fields were pastures and which ones were hay fields, because they'd have to grow hay in order to feed the stock during the winter. And the hay fields had higher walls because they were always having to go in and pick up stones that had come up to the surface. And so they were always adding to the walls. And so the walls are taller. There are walls all over New England. This is one that's in Newtown, over by that old farm where they make ice cream these days. It's always appealed to me, this little angle in the field. I early in my career estimated the length of stone walls in the state of Connecticut as using high altitude photographs. I estimated as 20,347 miles in Connecticut of stone walls, okay, which was about 33 feet per acre. If you want it in kilometers, there it is. Turns out that the U.S. Department of Agriculture late in the 19th century did a manual labor on the ground sort of measurement and estimated something very similar for density of walls in adjacent New York. So I think I'm probably pretty close. Now, at first, when they were clearing fields, the farmers would cut down trees and use that wood for heating their homes, which they were never able to do sufficiently in Britain because the royals owned all of the forests. And they would also, use them for making houses and so on. And they dig up the roots and make a rough fence from them. And of course, being wooden fences, they would rot over time. And so the next thing that they would put up would be snake rail fences. Fences like split rails that you sometimes can see even today. And these were the ones that Abraham Lincoln became famous for cutting as the rail splitter back before he ran for president. And then later on, they would throw more stones on them because they had to do something with those. And sometimes there are stone walls that are zigzag following the form of the snake rail fence. They would also, if they had sheep, need to make them higher because sheep can climb where cows are not very good at it, and sheep and goats can climb. And so first they would put a rail fence on top of the stone. And later on, after barbed wire was invented, they came up with other things, barbed wire, when you can still find bits of barbed wire in some of these old farms. Stone walls that were built like around a church in a village were often much less random, they were much more organized and done neatly than were the ones around the fields. The cows didn't care how neat the stones were stacked up, whereas people wanted nice looking things in their homes and around churches and schools and so on. And so some of these stone walls, which were double walls, double rows of big rocks with little rocks in between, were built up for in-town use. And there are these stone walls here today. This is one of the stone walls that's out of the Nature Preserve and Westside campus, and you can see how much work by the way, these rocks are granite. They're heavy. They are not light things. And it's a lot of work for whoever was available to work to go out there and pull them out of the the surface of the ground and carry them to the edge and stack them up or toss them over. And sometimes they would just take the rocks to the edge and chuck it over the side. And so one side would be kind of more or less neat and vertical, and the other side was sloped, where the walls were just thrown over. This wall right here has a lot of stones in it. They're not really put together very neatly, because the field to the right was a hayfield and was for a long time, apparently. And so every summer or every spring, they'd have to go out and pull the rocks out, and they'd just carry them as far as they absolutely had to and then throw them over. And so there's a lot of rocks in this one wall. And it is a lovely place to go and walk around, and there's nature preserves all over Connecticut that are the remains of old forests, and you can walk through the old farm roads and have such a nice time in the fall and the spring and so on. Take your dog out for a run, take your kids out. Kids like running around. They're just a joy. And one of the things that is no longer here, which was at the beginning, were American chestnut. American chestnuts are a big nut tree that had lovely wood to make furniture and stuff out of. Just really nice. Some genius decided that what North America really need were Asian chestnuts back 130 years ago. And so they brought some over, and those chestnuts were resistant to and brought with them a fungal disease, which was spread by beetles. And the chestnut blight showed up around the Bronx in, around the turn of the 20th century, and then spread from there. And so by the time I got to Connecticut in the late 90s, the only chestnuts you would see were little sprouts growing up from the stumps of the old dead ones that had died of the chestnut blight. And that's what these are. And I hardly see them anymore. It's really a sad story, the loss of American chestnuts. And so at some point, the farmers decided that maybe farming was too much work, and they decided to go into town and work for other things. And so farming went on the wane, also helped along by the fact that Mr. McCormick invented his reaper, which was this machine that would be pulled by horses and would be able to harvest wheat and other grains much faster than people with scythes would. But they needed more room than you typically had in a little rectangular stone fenced New England field. And so the grain wasn't a economically viable crop anymore. And so there really wasn't much, an easy way to open up the fields. You had to do something with the stones and so on. And so people did other things. They let the fields go fallow, the trees came back, and we have what we have at our nature preserve today. And the farmers are not there anymore. And Henry David Thoreau, the poet and writer and odd duck in Massachusetts, noticed he was an observer of the natural world and the farms, and he wrote a little blurb about a little verse about the stone walls. He says, "How can their works," meaning the farmers, "be so visible and permanent, themselves so transient?" He wrote that in 1850 because I think the loss of farmland was beginning, particularly around towns and stuff. And with that, I would be glad to answer questions if I can.
If anyone has any questions, please put them in the the chat box.
By the way, that the stone walls was my first object of research when I first got here in 1996. And so a lot of this stuff is information I collected way back then that ever so often people still like to hear it. So here we are. It's a real New Englandy thing, you know.
Oh, it is. It is. Does anyone have any questions? Because if not, we can just call it an evening or an afternoon, whichever it is.
Can I,
Well, go ahead.
can I say it, something?
Sure.
Oh,
Go ahead.
in the Connecticut-New York state border, was there ever, stone walls used as a state border line?
I don't think, well, I can't say categorically no. I think that would be a lot of work. However, they probably they may have stacked up at the borders where the roads would cross the border. They would maybe stack up a big pile of them in a kind of an obelisk shape or something like that. Put a sign up there saying now entering New York or now entering Connecticut. That would be a reasonable thing because it wouldn't rot. You wouldn't have to replace it all the time.
Thanks.
So that's just my speculation. And yeah, I don't think there probably wouldn't be have been much need to keep the New Yorkers out of Connecticut and the Connecticuters out of New York. So that would have been way too much work.
Why are there not stone walls in the Midwest? Didn't they
Because-
also have recessed glaciers?
Good. Yeah, we didn't have the right kind of glaciers. That we didn't have glaciers that went down so far. They did not run over the top of granite mountains to pick up these rounded off stones. The geology isn't granite, it's other things. It's chert. In my grandmother's house in McDonald County, Missouri, the dominant rock at the surface is this sharp angled chert stuff called mosarkite that you don't want to walk on barefoot. It just wasn't the right kind of rock to build stone walls. And so probably by the time the farmers came into that area, they built barbed wire fences when they needed fences. Yeah, these farmers early on didn't have barbed wire until much later. And so you had to do something with the stone, and you also had to keep the neighbor's goats out of your corn. So stones are the way to do it.
Or did they actually acquire the barbed wire?
That would have been, I'm thinking it's probably after the Civil War, but I can't say for sure.
Yeah, because some of the barbed wire stone walls that I've encountered, that barbed wire is just old, ancient.
Yeah, there's a in our nature reserve, there is this kind of a stock chute down by a small creek that where the remains of a gate that had barbed wire on it. And so the farmer could open up the gate and let the livestock down to drink in the creek. Okay, and then keep them from running off when they weren't doing that. And so you can kind of read the landscape if you get some experience at it and figure out, okay, well, this is what this was in the farm. It's all very interesting for those of us who like history.
Indeed. We have another question. What is a glacier erratic and how do they differ from the rounded stones?
Glacial erratic is, those rounded stones are glacial erratic. So glacial erratic, I'm not a geologist, this is my understanding, is that a glacial erratic is a stone that a glacier will pick up in one area where that stone is common and carry it to some place where it is not. So we have all these granite boulders down here, which are, I'm not sure if they're technically erratic because I'm not sure what the geology is down down here if there's that much granite, but it would be something like that. It's something that's picked up by the glaciers and carried somewhere where it wasn't previously, and where that kind of rock is not found generally.
Great. Any other questions before we call it an evening? Okay, I guess that's it. So once again, I'd like to thank everyone for joining us this evening for another episode of Earth in Crisis. The next episode, next time that we're going to actually have the next talk is going to be, hold on, let me just check this out, is on March 20th at 6 p.m. So we're returning to Thursday night. And so until then, have a great rest of the evening. I think things will get a little bit more spring-like by that time. And thank you so much, Professor Wagener, and happy belated birthday.
Oh, thank you.
Awesome. Thanks a lot, everyone. We'll see you on the 20th.